Have you ever crossed a bridge and just wondered how on earth they build this thing? It's a journey of incredible human ingenuity, stretching back thousands of years. Let's take a walk through the history of bridge building. It all started with a simple arch. The Romans were absolute masters of it. Think about the Pont du Gard in France. It's almost 2,000 years old and still standing. The secret was the keystone. This single stone at the top of the arch distributes all the weight downwards and outwards, making the structure incredibly stable. For centuries, this was the go-to design, allowing them to build aqueducts and bridges that have literally stood the test of time. It was simple, elegant, and revolutionary. But as our ambitions grew, so did our need for stronger materials. Stone was great, but it had its limits. Enter the Industrial Revolution and the age of iron and steel. Suddenly, we could create structures that were lighter, stronger, and could span much greater distances. A perfect example is the Forth Bridge in Scotland, a massive cantilever bridge completed in 1890. It's a true beast of engineering, using over 50,000 tons of steel to create a structure that looks as powerful as it is. This shift from stone to steel wasn't just a material change. It completely redefined what was possible. Then came another game changer, suspension. The idea is brilliant. Instead of pushing down like an arch, a suspension bridge hangs from massive cables. These cables are anchored into the ground and draped over tall towers, carrying the load of the bridge deck. The result? Bridges that seem to float on air, spanning enormous distances. The Golden Gate Bridge is probably the most famous example. When it opened in 1937, it was the longest suspension bridge in the world. It's an icon, a symbol of San Francisco, and a testament to the elegance and power of suspension design. Fast forward to today, and we're in an entirely new era. Modern bridges aren't just static structures, they're smart. Take the Akashi Keikyo Bridge in Japan. It is packed with sensors that monitor everything from wind speed and traffic load to the slightest movement in the structure. This data is fed back to a central system in real time, allowing engineers to predict maintenance needs and ensure safety. It's like the bridge has its own nervous system. We also use advanced computer modeling to test thousands of design variations before a single piece of steel is even forged, optimizing for strength, efficiency, and cost. But the innovation doesn't stop with tech. We're also getting much smarter about the environment. Building a massive bridge can have a big impact, so engineers are developing new ways to minimize that footprint. The Millau Viaduct in France is a stunning example. It soars over a delicate valley, touching the ground in only 9 places. Its design is so light and airy that barely disturbs the landscape below. We're also using new, eco-friendly materials like advanced composites and recycled steel to build bridges that are not only strong, but also sustainable. And let's talk about those new materials. We're not just using steel anymore. Carbon fiber is making a huge splash. It's incredibly strong, lightweight, and resistant to corrosion. Bridges like the Sunshine Skyway in Florida have used carbon fiber to strengthen and protect their structures. This material allows for slender, more aesthetic designs that were once impossible. These modern marvels are more than just ways to get from point A to point B. They are symbols of our progress. They represent the perfect blend of art, science, and a deep respect for our environment. From the first stone arch to today's smart, sustainable giants, the story of bridges is the story of human ambition. It's about our constant desire to connect, to overcome obstacles, and to build a better future. What a journey, right? Thanks so much for watching. If you found this as fascinating as I do, hit that like button and consider subscribing for more deep dives into the world of engineering and design. See you in the next one.